Hello, I'm Linda Spate from the Fathom project at the University of Reading. For this presentation on the utilisation of SHEAR research, we invited people from different projects to explain how they are using SHEAR science data and tools in practice.
Hi, I'm Rebecca Emerton from the European Centre for Medium Range Weather Forecasts, or ECNWF. In 2019, SHEAR researchers from the University of Reading and the University of Bristol worked together with ECNWF to provide flood risk forecasts to DFID, the UK's Department for International Development, to help inform the international humanitarian response to tropical cyclones Idai and Kenneth in Mozambique. This was the first time that DFID and the UN Office for the Coordination of Humanitarian Affairs had received real-time flood forecasting and risk information to complement the cyclone forecasts and river level information from the national authorities in Mozambique and to help inform decision-making. Feedback from DFID and the UN OCHA was that this was the first time they were able to use science so early in planning for and responding to the devastating impacts of cyclones, and that this information helped to provide an overview of the rivers that were at greatest risk of flooding and therefore in which areas to focus the response.
Hi, I am Sajjad Hussain from the Flood Forecasting and Warning Center in Bangladesh and also a SHEAR PhD student at the University of Reading. SHEAR research is helping the Flood Forecasting and Warning Center to understand the flood drivers and to improve flood early warning for the Brahmaputra River basin in Bangladesh. In addition to our own 3-day forecast, we now use forecast from the Global Flood Awareness System to communicate warnings up to 10 days in advance to national and subnational authorities. In 2020, on the basis of this forecast, our Minister of Disaster Management and Relief ordered District Administrator to take necessary steps to prepare flood shelters and response activities.
Hi, I'm Mulangwa Douglas, a hydrologist with Ministry of Water and Environment, Uganda, and also a master's student at Makerere University, pursuing a Master of Science degree in setting. During the Fathom Summer Placement in 2019, I, along with colleagues from other countries, got introduced to the Global Flood Awareness System, GLOFAS, and how forecasts from GLOFAS can be used to inform early decision making and early action before a flood event occurs. I've been able to work with the scientists from University of Reading, and we've evaluated the forecasts from the Global Flood Awareness System. Our evaluation work has been used as an input into the development of the Early Action Protocol. The Early Action Protocol has been developed in conjunction with the Uganda Red Cross Society and other stakeholders. This is aimed at the implementation of the forecast-based financing approach in Uganda.
My name is Ntali Emmanuel. I am the Early Warning Early Action Officer for Uganda Red Cross. For the past 3 years, the Uganda Red Cross has been developing the forecast-based financing approach, an approach to enable it with its partners to deliver cost-effective, well-targeted and timely actions to the most vulnerable communities faced by a likely weather-related hazard. Informed by the first forecast-based activation in 2015, this process has been supported by a range of technical partners, right from the selection of meaningful actions to the real scientific analysis of the triggers and thresholds. University of Reading, through Fathom, has been very instrumental in supporting us and partners to define the trigger thresholds and facilitating a dialogue for determining the false alarm ratio. Through the skills analysis done by Dr. Andrea of the Fathom team, we were able to determine the GLOFAS stations in Uganda with a good skill that has enabled us to identify which locations we shall take action and at what percentages and false alarm ratios that we shall use to undertake anticipatory actions. We are glad that our early action protocol for floods has been completed and submitted for validation.
Hello, I'm Erica Thompson and I work at the London School of Economics in collaboration with the START network. Our SHEAR research project has helped to support the implementation of humanitarian action in advance of heat waves and cyclones, and to improve the process for using forecast data to raise an alert. We've discussed with national humanitarian representatives how they make use of publicly available forecasts. We've then used their feedback and experience to help the START network's anticipation team streamline the alert process. For example, developing templates that allow conditional activation of cyclone alerts, helping the process to begin even when there's high uncertainty about the impacts of a storm, and increasing the available time for a response.
Hello, this is Paddington Mukombwe, a master's student from Zimbabwe. I'm part of a team that is studying drought and flood events that are occurring in the Limpopo River Basin. So the purpose of this study is to identify and analyze the spatial and temporal effects of drought and flood events that are being experienced in the region. To achieve this, information is preserved in dam sediments, can be used after a thorough analysis of the sediment's organic matter, grain size distribution, and metal content. The sediment results can thus be correlated with recorded rainfall data in order to reconstruct the historical records of drought and flood events. These dam sediments were collected from major reservoirs that lie within the Limpopo River Basin through point sampling using a gravity core. Thank you.
So we finally arrived at the Zoe Dam in southern Zimbabwe, where we're starting our field work, and we're going to get the first sample of cores in a 75 millimeter pipe. So we're gonna use a gravity core, and we hope to retrieve at least 1.5 meters of sediments. At Bust, we're going to study the presence of flood and drought couplets, which are alternation of sand and mud produced by the episodes of floods into the basin. So we are now heading toward that island, halfway to in a water that is probably going to be 5 to 10 meters deep, and we're gonna drop the gravity core.
We are the Botswana team working on work package 2. I am Sitabile Triwarombo, a co-investigator.
Hello everyone, I'm Bipelo Tende. I'm the research assistant.
Hi, I'm Ongawisi Patel. I'm also the research assistant.
Our experience with the communities was that they are very much aware of the location of their water resources in their catchment, and also they are able to foretell when a flood or a drought event is coming based on their indigenous knowledge and their experience.
That was a snapshot of some of the projects where SHEAR research is being used in practice. There are many other examples that could have been included. The common theme across all these cases is working with people from local universities and organisations, showing the value of multi-sector collaboration between NGOs, governments, modellers and academics. Many lessons have been learnt on all sides about how to work together effectively. Some of these activities were planned into the original SHEAR proposals, others have developed organically along the way, often as a result of humanitarian organisations knowing how and where to contact experts through SHEAR. This knowledge network will continue to have benefits long beyond the end of the SHEAR programme. In all cases, practitioners have benefited from the ability to make decisions informed by science.